Why I want to do this one is I want to see the graph of the of the original function, like the fx function, not the derivative function. I want to see the graph of the original function. Say in some case I can't anti-derive the function. Say dy dx equals to x plus y. I don't know how to anti-diff that by hand, but I can draw the slope field and or provide us the slope field. I can see the shape of the graph. What is a slope field? What is slope field? I want just um let's say we have a graph like this, something like this. Maybe not this part. Yes, that would definitely pass. Okay. Um, if I have this function and I want to, what's actually slope field? Slope field is the gradient at each single point. Like if I can draw the gradient at different points, for example, like that. And I can do like more closely, like smaller, guys, like with more like smaller steps, I can do more and more like that. Then that will provide us a slope field. So basically, slope field is the gradient of the tangent, and I'm sketching those gradient like really small pieces, and in all together will give us the slope field. So let's just look at one example. Sketch the slope field for the differential equation dy dx equals to x plus y. Dy dx equals x plus y. So your gradient at each single point is just adding the x and y value together. So we just add the coordinates of x and y. So if we see this table, I will just complete one row. So I'll pick a middle one to do. Like I'll pick this one to do. So if the x value is 0 and the y value is those values, the gradient will be negative 3, negative 2, negative 1, 0, 1, 2, and 3. Well, we can do the same thing for all the other like boxes, but I'll just pick one row to do it. So negative 3, negative 2, negative 1, 0, 1, 2, and 3. So we can actually draw the slope field by ourselves on those points. So when x equals to 0 and y take different values, which I'm talking about x equals to 0, y taking different values, I'm talking about the slope field on this vertical line on the y-axis. So when x equals to 0, y equals to 0, the gradient is what? 0. So we have a horizontal line. The gradient equals to 0. So we have a horizontal line here. When x equals to 0, y equals to 1, gradient is 1, which means tangent theta equals to 1, which is the 45 degrees. So that's the 45 degrees slope field. And the next one, x equals to 0, y equals to 2. Gradient should be 2, which means tangent theta equals to 2. So if you have tangent theta equals to 2, which is, you can see this line got tangent theta equals to 2. Okay, 2 over 1. So I can draw the slope field just by draw it like that. Sorry, not the correct place. Here. At this point, gradient is 2. And the next one, 0, 3, gradient should give you 3. So which is even steeper like that. I can do this on all the other points, okay, any points. If you know the x and y values, we can just find the gradient and draw the slope field. So for negative 1, 0, negative 1, I have negative 1, like negative 45 degrees. And for 0, negative 2, I have go this way, which is negative 2, and negative 3 will go steeper like that. Kind of I draw the slope field for one column when x equals to 0 and I change in y values. I got those ones. And all the places can be done by the similar way. So I'm not going to complete the rest of it. That's how we make a slope field. Okay, that's how we make a slope field. Okay. not looking at the next page, we just go to page 14 to have a look at this question here. Can you see, like, we have lines like that? You can see the trend of the gradient. You know, if you go past like the trend of all the gradient and connect that, that will provide you the graph. But why we have so many graphs? The question is why we have so many graphs. C value is changing, so it's actually moving vertically up and down. So it's actually the same graph, but we're moving up and down by the C values. So we have infinite many solutions on the slope field. But if I give you 1 point, provide you 1 point, you should be able to see the specific solution. For example, this question here, it gives us dy dx equals to negative x minus y. So that gives us negative x minus y. It's showing you above. I think the type of questions start changing from 2016. In the previous years, like before 2016, the questions is most likely like those ones I provide you, that give you a slope field and ask you which one of these differential equations satisfy the slope field. But after 2016, the questions becomes more like the application part, like give you the slope field and give you a point and ask you what could be a solution, what's the solution graph looks like. So I know this is the slope field and I know a point 0, negative 1 on this actual solution. So from like the graph will pass 0, negative 1, and I can see the trend of the graph should be more like that. Roughly, it's not going to be exact, and they allow like a range, say from 2.4 to 2.6 is the allowed value. So you can, if you have values in between that, they will accept the answer. So 2016, I think 2016 is this question here, and the last year or the year before is a question on part 1 exam. Really ask you to draw the slope field, the solution to it, and they ask you to use your graph to approximate what's the y fx equals to 0 value. Like you should read from your graph. Hmm? No, not ask you to draw the slope field. They give you the slope field and give you a point on the slope field. Ask you to draw the solution graph, like the fx graph. So like that. Yeah. And the question is asking those 5 points, which one is most likely to be on the fx graph? So in this question, which is easy, I just label all the points. Negative 3, negative 1, which is A, is here. 3.5, negative 2.5 is kind of here. This one, yes. This one is basically to see where's the graph, where's the points, and then which one is most close to the graph. Negative 1.5 and negative 2, which is D, is here. 2.5 and negative 1 is here, which is D. And 2.5 and 1, this one is not going to be on the graph. Which one will be the answer? It's quite obvious. B will be the answer. So it's trial and error for this one. That's like what's going on for the recent years. They will ask you to draw the solution graph. They ask you to draw the solution graph. All right, just talk about like in case that will still come back for those questions, give you the slope field and ask you which differential equation you might have. Guys, I'll be really quick. Please be quiet. Just talk about a couple of ways what we should check. If provide us the slope field and ask us which one of the differential equations satisfy the slope field, the first thing we'll check is horizontal, like horizontally and vertically. Just fix one row and fix one column to see the slope field. If on each line horizontally, okay, think about all the points on one horizontal line. X value doesn't change or Y value doesn't change for the coordinates. Like, you know, in the Cartesian plane, on this, all the points on this horizontal line, what value doesn't change? X value or Y value? Y value doesn't change. So X is changing. X is changing. So X changes, Y not. So if the slope field change, if the slope changes on this horizontal line, which means dy dx involves X. Let's have a think about that. So on horizontal line, if your differential equation doesn't have X involved, which means you only have Y involved in your differential equation, then on each horizontal line, the gradient shouldn't change because it's only related to Y, not related to X. But if it starts changing, which means that will change because of there's X involved. So this one can reject some value. I'll go through that with you like in questions. So when you fix a vertical line, Y change, X not. If slope changes, which means dy dx involves Y. I'll take example to discuss with you. Okay, let's have a look at this one. Look at the options. Can you see there are 5 differential equations? Some of that only has X. Can you see this one only got X? This one got both X and Y, both X and Y. Only have Y, only have X. So this one's really easy to reject which one's not correct. So if you look at the vertical line, just any vertical, do you think the value changes? Yeah, and look at one horizontal, any horizontal line. Do you think the slope changes? Yes. So which means in this differential equation, you will have both X and Y involved in your answer. Okay, so everything in ADE is not going to be correct. That's like it's more like try and error. You reject things and then you limit to 2 answers and you select one. All right. The next thing is that's the first thing to check when you have both X and Y involved or only X or only Y involved. The second thing we need to check is zero gradient or undefined gradient. Okay, to see on the graph, do you have zero gradient somewhere or do you have undefined gradient somewhere? Okay, you can work backwards from your answer as well. After I check this one, just use example 3 as the example. Let's have a look. If the answer is C, if the answer is C, where you should have undefined gradient when y equals to 0, right? But do you actually have undefined gradient on y equals to 0? Do you have undefined gradient on y equals to 0? This line is y equals to 0. Is that the gradient undefined or not? Is defined or undefined? Defined. So it can't be C because y equals to 0 should be undefined. I will talk about that later. I'll use an easy example. I'll keep going with that. So after I reject all the solutions, B will be the correct answer. So A, D, E is not going to be correct. And then from C, I know y equals to 0. If it's C, then y equals to 0 should be undefined. But it's actually not undefined, which means C is not correct. Then B will be the correct answer. All right. Harris asked me about like the undefined value for ABC, like for question 1. Let's have a look at that. There's no point for me to check vertically or horizontally in this question because it's all the solutions get X and Y involved. Okay, all the answers get X, Y involved. Let's think about undefined value. What should be undefined on part A? Y equals to 0, right? But if you look at Y equals to 0, it's not undefined. Undefined is a vertical line or without sketching anything. Let's have a look. Sometimes it's hard to read from undefined. Like it's very hard to see it. Okay. x equals, let if you no, just put a question mark. I can, there's multiple ways to test it. You not really only rely on the undefined thing. So that's just some tool to help you to reject some answers. Let's think about b, like x equals to 0. Again, like you can see x equals to 0, like this vertical on the y-axis, it's not really looks like undefined. There's a value like negative 45 degrees there. So b is not going to be rejected. Um, what will be undefined on c? When x equals to y, right? But when x equals to y is which line? Is this line, right? But what do you realize when is x equals to y? It's 0, right? And the other one will be x equals to negative y, which will be the other line here. Like that looks undefined. Can you see that? That looks undefined. And also you get x minus y equals to 0, which is 0 gradient. 0 gradient should be, can you see like on this line y equals to x, actually you get 0 gradient. And on the other line you have the undefined gradient. So answer will most likely be E here. Um, Another thing, well, I'll just go through finishing like what I need to check. There's one last thing after like go step one, step two, it doesn't work. I don't know, still don't know which one to select. The third step we need to think about is positive gradient or negative gradient. Give you some example. It's not going to be uniform for all the questions. Let's say if you can't decide y divide whether it's y divided x or y plus x. If you left those two to decide, like I want to pick one of this answer, like dy dx is either y divided by x or y plus x, what's the method to think about? If you think about positive gradient or negative gradient, in which quadrant it will give you very different answer. Think about third quadrant, what will happen? In the third quadrant, what will happen? Sorry, yeah? Or in the third quadrant, x, y is both negative, right? They cancel, so this one will give you positive gradient. And how about this one? Still negative. So if you look at the third quadrant, you can decide whether it's a positive gradient or negative gradient, and you can decide which one is the proper one. It's not always looking at the third quadrant. It depends on different questions. Sometimes you look at like x greater than something, whether you get a positive gradient or negative gradient. For example, if you have x times x minus 2 or x times 2 minus x, you want to select one, like which one, what value you look at. Like if you leave those two to select, which one you, what value you look at. I will see x greater than 2. If x is greater than 2, this will give you a positive gradient, and this one will give you a negative gradient. And in this case, I can decide which one to pick. So by different questions, you will look at different features, and that's not really uniform. Okay, so basically by those three steps, you can decide all the solutions. Like you definitely will work out the correct answer. Okay, definitely work out the correct answer. I don't have enough time to go through examples with you, but I will recommend you complete this one and I'll check answer with you. I will circle the answers on this one, and you can check your answer with me on the class notes. Okay, so it's quite important to think about a couple of questions. At least complete the first page. Okay, at least complete the first page. There was a question not really nice. You don't need to try 6. Okay, don't need to work on 6. 6 is a bit too hard to think about. So don't worry about 6. Try the rest of the questions. And now I'm going to return your fact papers. I can't remember which one. It's either A or B. It's either A or B. I need to do a bit calculation to see it.